recording. Yep, okay. All right, so this is AP Bio, and this is our final day of the lab day 2. All right, so we have our notes in front of us of what we're gonna do. And we're gonna first start by looking at the baggies, and we're gonna mass our baggies, and we're gonna mass our potatoes. We are looking at the baggies to see how they changed, and we're gonna weigh them, and we're gonna also weigh the potatoes, okay? Last class, I think I used the different numbers on here, so you can go ahead and pause the video, write these numbers down for your mass so that you can see what they are, because we'll go from here in our notes, okay? All right, so I can come over here. It says to take the baggie out, but don't put it on paper, okay? So we don't want the baggie to hit the paper because it'll pull water from the paper. So you're just kind of taking it and shaking it a little bit, and then here's a scale. Use that scale, okay? And I'm just kind of dripping it. I know this is making a mess. So you can grab one in here, okay? And you can take that one. Okay, kind of shaking it, but don't drop it. Okay. All right. And mine is, this is the albumin one. So now I'm gonna weigh it, make sure my scale's at 0 and in grams. I'm gonna weigh it. Okay, you guys do the same. All right, the albumin was in beaker C, was the albumin. Okay. Beaker A was the glucose, and beaker B was the salt. All right, so what did we get? My mass here for the final mass of my albumin is at 8.0 grams, okay? What was the initial mass of our albumin? Our initial mass was 9.6 grams, okay? I'm done with this, now I can throw this away. All right, my student, let's see, who had the glucose?
This is salt.
Okay, so you have the glucose. All right, what was the initial mass of our glucose?
6.3 grams.
Okay, 6.3 grams, and what is it today?
It's 6.6 grams.
6.6 grams, okay? And then what was your initial one?
I was just saying remind you.
Okay, she's gonna go look at it?
Yeah.
Okay.
5.7.
Okay, so it's 5.7 grams, and what did it get to today?
5.6.
5.6 grams, so not very much of a change here, okay? So I can definitely see this is the one that had the biggest change, okay? All right, we gotta calculate percent change. So we calculate percent change by, let me find it on my paper here, upside down and backwards. All right, right here, okay? The final mass minus the initial mass divided by the initial. We actually want to times this by 100 to get that percent change, okay? So I'm going to have you guys do that. If you want to grab a calculator from over here. Yeah. Okay. My at-home kids, you should be able to do this and calculate your percent change on here. Remember, here's the formula right here. Final mass minus initial mass divided by the initial times 100 to give me that percent change.
Yeah, it's going down. It's 5.4, 5.5. It's like alternating right there. It's 5.4 now.
We'll stick to the 5.6,
All right.
okay? Because it's probably losing it to the air around it. Yeah, you can take that. Okay. So final minus initial, so I'm going to do this one. It's final minus initial. Okay, that number, then divided by the initial. okay, and then times 100. So I'll tell you that this one's percent change was a 4.76%. And it's a positive number, so I knew it grew. And you can see that it grew. Okay, so if you got a negative number, like this one's gonna get a negative number because it shrank.
Negative 1.7.
Negative 1.7?
Yeah.
Negative 1.7 grams. Okay, and then what about this one? You do that one?
Oh, I do that one.
You did this one?
Yeah.
Okay. Let's do that one too. Okay, what you got?
Negative 16.
Okay, I got negative 20. So if we both got different numbers, let's do it again, okay? Final mass is 8, so 8 minus 9.6, okay, equals negative 1.6, divided by the initial, 9.6, you were right, I was wrong, times 100, okay? So now I got the same number you did, okay? Anytime we're doing stuff and we get different numbers, it's better to just do it again. 16.67, because it's a repeat on there. All right, and these are percent changes down here. All right, so what kind of solution was the first one? Was this a hypotonic, isotonic, or hypertonic? It got bigger.
Hypo.
Hypotonic, okay? Can't write upside down. All right, what about here? Okay, we could argue that it didn't change very much, okay? That could even have been an error in us or anything else. So I would say at a negative 1.7, that difference, it's probably an isotonic. It probably didn't move that much. All right, but what about here? All right, we had a negative 16. It lost a lot, 16% change. So what is this one? Okay, I would say hypertonic also. And I would guess this one's isotonic. Okay, all right, so that's really good, okay? All right, next thing we gotta do is our potatoes. So we're gonna mass our potatoes. Did you all write these out, different colors at the top?
It was the colors, yeah.
Okay, what did you put for number 1? I wanna keep the same things you guys did.
It's on the computer. Wow, I did.
Yeah.
I did red, blue, yellow.
Okay, hold on, number 1, you put red.
Yeah.
Okay, what was 2?
Blue.
Blue. All right, what was 3?
Yellow.
Yellow.
Yeah.
What was 4?
Green.
Green. And 5?
Orange.
Orange. And then 6.
Like that dark blue or whatever.
Okay.
I put dark blue.
Yeah, it's like indigo. Let's just put dark blue. Okay. There's probably a better word for it, but lapis. That's the word. Lapis.
Lapis.
Yep. My sister's bridesmaids' dresses were lapis. Okay. So here we have at the top the initials mass. So I'm gonna have you guys. You're gonna stick your fingers in it. It's sugary. Okay. And you're gonna try to shake the potato, but don't touch the paper. We're gonna mass the potato. And why don't you write on the potato or on that cup? And any Sharpies out in the room. All my Sharpies go missing all the time. Here. Okay. Here we go. Okay. All right, you guys can write the mass on the cup so we can put our new mass at the bottom. Okay. And I'm going to put the initial one. So the initial of 1.7 grams. Okay. And then the blue, we're going to keep the solution, 2.1 grams.
So I'll pull it out and weigh it.
Just pull it out and weigh it. Yellow. Okay. Green. See, this is why my online kids need to come back. They're missing out on all this fun.
Feels so weird.
It does. So you can describe like how the potato feels. At first they were kind of hard, but what are they feeling now?
Like like slimy.
Slimy? Okay, that could just be like fungus.
It's so soft.
Okay. All right, I'll let you collect those. All right, so I think you guys can see on here, and you can see on the cups too. So we had the red was at 1.7 grams, the blue was at 2.1 grams, the yellow is at 2.4 grams, the green is at 1.4 grams, orange at 2.1 grams, and the dark blue is at 1.8 grams. Okay, and then we're getting the final masses on all these. What was the red one?
1.4.
1.4 grams. Okay. Did you get the blue one?
Yeah, it's 1.7.
1.7 grams. And let's wipe off the
water.
the water on here so we're not getting any bad data. Okay. There you go. Which one did you just do?
Orange.
Orange, what'd you get?
2.6 grams.
2.6 grams.
This one was 1.9.
And that's the dark blue, right?
Yeah.
1.9?
Yeah.
Okay.
This one's 1.0 grams.
1.2 grams. Thank you. The green. Okay, oh yeah.
This
Yeah.
one was 2.5.
Okay, 2.5 of the yellow, 2.5 grams. Okay. All right, we got to do the same thing of calculating the percent change on all of these. All right. Remember, it's behind me. It's the final minus the initial divided by the initial. Okay. You see it up there above the red? Okay. And then times it by 100. All right. You want to do the first one? So the the final was 1.4 minus 1.7 equals, okay, divided by the initial 1.7. Okay. What'd you get? Oh, then times 100, sorry.
Negative 17.6.
Good, I got the same thing, negative 17.6%. Okay. All right, we're gonna do the blue. Okay, we get 1.7 minus 2.1 divided by 1. Okay, times 100. What'd you get?
Negative 19.
Good deal, me too. Negative 19.04, so I'm gonna just put the 0.4%. It's always good to go the hundredth. Okay, what about the yellow? 5 minus 4 divided by. Okay, what'd you guys get?
I got 4.
I got 4.166.
Yeah,
Okay.
4.166.
So we'll say 4.17%. All right, the green one. What'd you get?
Negative 28.5.
Okay, I didn't. I got negative 14.
Me too.
You did too? All right, let's do it one more time. Make sure we did it right. Final first.
Are we doing the which one? Yeah.
The green.
The green?
Yep. I got the same thing. What'd you get? I got
The
negative
same thing.
14.28.
Yeah.
Okay, good deal. Percent. All right, let's do the orange one. Yep. There. Okay. $23.8. Yep. Okay. 23.80%. Actually, it's 81% would be more accurate there. Okay. All right, last one. What do we get? 5.56.
Yeah.
5.56%. Okay, so we want to think that, first of all, let's label what they are. This one got a lot smaller, so what kind of solution? Hypotonic, hypertonic, or isotonic? Hyper, okay. All right, this one, blue, it's a negative. Hypertonic. Okay. The yellow, hypo, okay. All right, the green, hyper. Okay. The orange, boy, that one grew a whole bunch. What do we say? Hypo. And then the dark blue, we said it grew by 5%, so that would be a hypotonic. Okay, so in density, we want to think, we put our spuds in here. If the solution, here's our potato, okay? If the solution has a lot of particles, it's really, really dense. If it has a lot of particles, from being dense, the water should move out. So the more dense the solution, the more should move out. Does that kind of make sense? So the biggest one we had to move out was the blue. Okay, so I'm going to put a little 1 here. Who would be the second? Second density, probably the red. Okay, let's put a 2 here. All right, then we go up. Who's our next? Green, 3. Who's our next? Yellow? He's at 4. Okay, so he's 4. The dark blue is at 5%. And then finally we get to that orange one, so that's a 6. Okay, this had a big gain. So I'm guessing that this was the plain water solution. Okay, all right, so the other thing we have to do is you have to think about the other solutions and what is their molarity. So we think, we're guessing that based on this, that the water is orange, okay? So if this is orange, then we have to think about who is 0.2, just a little sucrose, not as dense. Who's 0.4, a little bit more dense. The most dense is at a 1. So if we go back here, the one that caused the most change, this one, we would guess that this is 1 mole of C6H12O6. Okay? All right. I'll let you at home work on that. You guys will work on it in a minute. Okay? All right. The other cool thing that we can do is we can test this out. Okay? We can make a density chamber. All right? So we're going to use pipettes, and actually we are going to just use also our solution. Okay? So we have our solutions right here. We might want to stir it up a little bit because they're starting to get a little sticky on the bottom. All right, who do we see was the most dense? Who do we pick?
The most dense was the blue.
Okay. I think we said the blue. Okay. So if that's true, if the blue is the most dense, my stuff is sticking. Okay. Then I should be able to suck up some of this, put it in the tube, okay? And the next layer we said was what? The red. The red should float on top. If the red doesn't float, then it might be wrong, okay? When we do this, we want to go slow. Don't just squish it in there. Like hit it to the side and see if it'll go down, okay? So for at home, I already took a picture of my density column, so you can use that at home and be able to look at that to see if it matches our data. If it doesn't match our data, it's okay. We're just saying that it doesn't match, and there must have been a flaw somewhere. The flaw could have been that I didn't refrigerate this stuff, that it started to separate out in the container. The flaw could have been that we left our experiment for 100 different biology kids to mess with, okay? There could be lots of flaws, but that's part of doing the experiment. All right, while we work on that, the other thing you all have to do is down here on question number 6, we have to create a graph for our potato lab, okay? And I wanted to go over independent and dependent factors because I felt like a lot of my kids were missing that. When I say independent, I always say what affects what, independent affects dependent. That makes sense, the dependent matters. So what affects what? Independent affects dependent. So what are the two things that we had change? We changed solution, and we had the percent change, the mass. So did the solutions affect the percent change, or did the percent change affect the solution?
The solutions affect the
Right, the solutions affect the percent change. So my solutions need to be on the x-axis at the bottom of my graph. The percent change needs to be the y at the top, okay? All right, and for this last one, we got to create that graph. What kind of graph should we use for our data? Would a line graph work for this data? No, it wouldn't, okay? A bar graph would be better, okay? A bar graph with each of the solutions and then the percent going up. So don't forget, you got to add that part onto the lab report, okay? And then basically it's done, okay? All right, we're going to play with our density columns, and they are going to be worked.